the center of mass of a thin wire and its ends, they are subtending the angle alpha with the x-axis. This angle which is made is 2 alpha. Obviously we have to look for the axis symmetry. We place it like this so that it is on the axis symmetry. So alpha is here, so total angle is 2 alpha. Radius is r. So we have to find the center of mass of this wire. We have understood when the mass is distributed over length, it becomes xcm, or x bar becomes integral x dl by integral dl with appropriate limits. If it is spread over area, it takes the form x dA integral over integral dA. Otherwise, when it is spread over volume, or in all the cases, generally if we intend to apply, we can always use integral x dm over integral dm. Because over here the mass is distributed over length, so we can easily use this formula x bar is equal to integral x dl by dl. So what to do is, at a general angle theta, we take a very small section of this subtending angle d theta. So this angle enclosed is d theta, the differential element theta. We know that is s is equal to r theta. This is a relation we have used number of times. S is equal to r theta, that is length of arc is equal to r times theta is the angle enclosed in radians. So this length is a very small section. Its length becomes equal to r into d theta is the angle enclosed, so this becomes r d theta. Now this is r, this angle is theta, so this for distance from here to here of this element, it comes out to be r cos theta. So the distance from here to here of this element is r cos theta. We have x dl over integral dl. So x is what? X is going to be, what is the distance of this particle from here? It is going to be r cos theta. This is r cos theta. And what is dl? dl is r into d theta. So r into d theta over integral r d theta. If we integrate it from here to here, obviously we will get the total length. That is integral of dl is going to be that much only. And what are the limits of theta? Theta is varying from, that is from minus alpha to plus alpha. It is going from minus alpha to plus alpha. So limits of theta, that it varies from minus alpha to plus alpha. So obviously now it is simple, that is r square cos theta d theta, and over here r integral of d theta is theta only, so r into d theta. So this makes r square cos theta d theta integral over integral of r d theta. Integral of cos theta is sin theta, so r square sin theta limits minus alpha to plus alpha, and over here this will make r into theta, integral will make r into theta. So r into theta, theta goes from, let's say, minus alpha to plus alpha. So it is, first we put the upper limit, so alpha minus, this is minus alpha, which will make 2 alpha, and over here we say sin theta minus alpha to plus alpha. So first we put the upper limit, so sin alpha minus, then we put the lower limit, that is minus alpha. We know over here in the quadrant, first quadrant, all sin, tan, cos. That is how we know it. Over here all is positive, sin is positive, tan is positive, cos is positive. So sin minus alpha is going to be minus sin alpha, because in this quadrant only cos is positive. So minus, so sin minus alpha is minus sin alpha, so that makes plus sin alpha. So sin alpha plus sin alpha, that makes 2 sin alpha. It comes over here, we put the value, and it comes out to be r sin alpha by alpha. This is the center of mass of this wire. So this is the center of mass of this thin wire.